This segment will discuss the most common numerical converter instructions in the Step 7 processor at a general level. Further segments will give a more specific example of each instruction. First, we will discuss the various instructions, and then we'll provide a general example. In the Step 7 processors, mathematical or comparison operations can only be performed on values that are of the same data type. For example, you can only add a real number to another real number, or compare an integer to another integer. If your initial values are of different data types, you must convert one of them before performing the final math or comparison operation. If you are dealing with BCD data, there are 4 instructions that will be of use to you. You can convert from BCD to integer or double integer using the BCDI or BCDDI instructions. These instructions are also called the BTI and BTD in the statementless programming language. The BCDI instruction will read a 3-digit BCD value, up to 999, and convert it to a 16-bit integer value. The BCDDI will take up to a 7-digit BCD number and convert it into a 32-bit double integer. There are also instructions that perform the opposite function. The IBCD and DIBCD will convert integer or double integer values into a 3 or 7-digit BCD value respectively. Next, we will look at converting integer and double integer numbers. The key functions for this include converting integer to double integer using the IDI or ITD instruction. This will convert a 16-bit signed integer number into a 32-bit double integer value. The next one is the DIR or DTR instruction. It will take a 32-bit double integer value and convert it to a 32-bit real number in exponential format. In the last section, we'll look at converting real numbers. There are several instructions that will allow you to convert a real number to a double integer. The difference in them is based upon the result that you want and how you treat the fractional portion. The result of the round instruction will be a double integer value that is closest to the real number. For example, if the decimal portion is less than or equal to 0.5, then the instruction will round down the value to the next lowest whole number. It will round up if the fractional portion is greater than 0.5. The floor instruction will always perform a round down, while the ceiling instruction will provide you with a round up function. The last instruction to look at is the truncate. This will provide you with a result that is equal to the whole number portion of the input word. In essence, it drops the decimal point. When you are performing conversion operations, you must keep in mind both the data type that you ultimately need and also the valid converter instructions. In some situations, you may need to do the conversion in a couple of steps. Let's look at some examples to explain these points. First, assume that I need to add together two values. One is an integer, and the other is a double integer. Because there is no way to convert the double integer to an integer, I am forced to deal with both numbers as double integers. So, I would first convert the integer to a double using the IDI or ITD instruction. Then, they can be added as double integers. Next, let's say I was to require the comparison of a real number to one that is an integer. Looking at the available instructions, I have some choices. If I wanted to perform the comparison in the real format to preserve the decimal point, I would first need to convert the integer to a double, and then convert the resulting double integer to a real. I can then compare the two real numbers. Another choice would be to convert the integer to a double integer, and then also convert the real number to a double integer, using a round instruction, for example. In either case, the operation requires 2 steps before I can compare the values. This has been a general overview of the data conversion instructions. Further details and programming examples for some of the specific instructions, as well as a discussion on the differences in performing these operations in ladder logic versus statement list, are all available in separate segments.